Welcome to the screencast on testing for ICS 211. When I was a manager, one of my favorite interview questions was, how do you know your code works? And that's a great question for interviewees or managers to find out how a software engineer knows that they've created good code. And one of the key answers to that question is that they have tested their code. So we're going to talk about testing today. There are many different levels of testing, and they correspond to the different levels of requirements design, coding in the waterfall development process. At the lowest level, we have unit testing, where we test each of the fundamental units of the code. If you're using object-oriented, we're talking about testing the classes and all public methods of those classes. The second level of testing is integration testing, where you're actually testing the design of your program, and you're saying, does the code does it work together? Do the classes play well with each other? Does the class A call the right methods in class B? Is the behavior and the interaction between the classes correct? The next higher level is system testing, where you're testing the program to make sure that it's doing what it's supposed to do. Often you test the use cases, for example, allowing someone to sign up for something, or creating a logging into the system, creating a new database, whatever the program is doing. You want to test the stories or the behaviors or the requirements of the program. And the last layer of testing is actually acceptance testing, and that's where you're basically doing system testing for the customer on their hardware or at the place that it's going to be run. So this is sort of similar to requirement system testing, but you're getting buy-in from the person who is actually going to be using the program. So that's the highest level of testing. Just talked about the levels of testing. There's basically two types of testing. The first type of testing is black box, where you don't have to know anything about the particular implementation of the class. We just want to know what the public interface is, and we're testing the behavior of the class. So, for example, we would say we have an array list. We don't care that it's an array list. We know it's a list. Here are some of the public methods. So we would say, well, how would I test its behavior? I would potentially create an empty list, try to see that its size is 0, try to remove something at index 0. There's empty, that should cause some sort of exception or something. I should try to ask whether it contains something, that should return false. Try to iterate over it, should have no, it shouldn't loop any times. And then I could start doing things like adding an item to the list, check its size, try to get that item, change that item, search for the item. There's all sorts of behavior I can test without actually knowing anything about the actual implementation of the class. We want to test the input parameters, so we want to say, oh, if I give a good index, I should get a good value. If I give a bad index, I should get the behavior as expected. What if I try to set an element as null? What's the behavior that I expect? Remove an index, remove a negative index, all sorts of, so I'm testing a wide variety of the parameters for the methods because I don't actually care about the internal implementation. The second type of testing is white box, where we actually know what the implementation is, and in this case we're going to try to test the different branches inside the method. For example, with this add method, if I was doing black box testing, I would just add. In white box testing, I would create a test case where I make the size, I add enough items to make the size equal to the internal array length to test to see that the reallocate method actually works correctly, doesn't cause any problems. That is a more detailed level of testing, and it does require a lot more knowledge on the tester and the building up of the tests. What white box testing also allows us to do is code coverage. You can see in this slide where a tool is reporting how many, for the methods that I've tested, I've tested the constructor, the static, the do initial, do init, calculate the value in the do retrieve method. However, the do retrieve method, I missed about 40% of the instructions and about 18% of the branches. Now this is Whitebox testing. I could create more tests for the do retrieve to improve that score, but it is complicated. The tools might also show you specifically which lines of code actually got tested. The greens are the ones that actually got executed during the tests. Yellow are conditionals that got half or partially tested. They're executed but not both values were not true. The red lines were just not executed in the particular set of tests. So you can get a lot of information and a lot of detail when you use Whitebox testing. It is much more difficult to create all the possible scenarios to execute every possible branch or branch of your code. It can take a lot of time, but you often want to do both black box and white box testing to improve your code coverage. One thing I suggest for testing in general, in Java, use JUnit. It's a wonderful tool that you can use both black and white box testing. You can set up tests such that they test just the behavior. You can also set up additional test cases to set up the situation so that you know that you're going to execute particular branches inside your code. You should test all your classes. Each of your classes should have a JUnit corresponding JUnit test that tests all the public methods. You should always test all the public methods in at minimum. By using testing, both white box and black box testing, you then can answer the question, does your code work? You do know that your code works in all the tested possibilities. You cannot test all possible combinations, but you get a very high level of confidence that your code does work. Thank you for watching this screencast on testing.